Hello, everybody. This is Dr. Vahid Aryadoost. In this video, I'm going to discuss some of the most frequently asked questions in my statistics classes. Students often confuse concepts like standard deviation and standard error of the mean, and they don't understand what the confidence interval means. In this presentation, I'm going to demonstrate what these four concepts are. The reason why I have included the mean is that these three concepts are closely related to it. So I decided to include it in this video. Let's get started with the concept of the mean. I think this is very well known to everybody, so I don't spend too much time on it. Mean is simply the mathematical average of two or more numbers. When we want to calculate the mean, as you know, we sum all the numbers up and then we divided it by the sample size. The mathematical notation of the mean is represented here. The X bar represents the mean itself, which is calculated by dividing this index by the sample size. And this sign here is basically sigma, which means sum. So you sum all of the scores in your variable, like these scores together, right here, and then you divide it by the number of the scores. In this case, I have already done that. I have summed them up, which has given me 60, and then I divided it by 11, which gave me 5.45 and more decimals. I'm going to use this mean to demonstrate what the concept of standard deviation and a standard error of the mean, as well as confidence intervals, mean. The first thing that I would like to talk about is standard deviation. Let me just draw a simple graph here for you. This graph represents a mean of the sample, which is equal to 545, almost 545. I'm rounding it off. On the two sides of the mean value, we have a spread of different indices. For example, to the left-hand side of the mean, that's below the mean, we have indices like 5. As you can see here, we've got 5, we've got another 5, we've got another 5. So I represent 5s here as this by this line. And then another line represents 4, and another bar represents the 3 in this distribution. On the other side of the distribution, I have values such as 6. As you can see, I have 6, 7, 8, and 9. So 6, 7, 8, and 9. It's very obvious that the data included in this variable are spread on both sides of the mean value. Now, the question is, can this spread be summarized into one useful index? And the answer is yes, of course, it can be summarized. It can be captured by one specific value, which, as you know, is called the standard deviation. Therefore, the standard deviation measures how much spread or the variability there is in our data set. How do you calculate standard deviations? It's actually easy. I'm sure that you know this, but let me just walk you through it very quickly. The first thing that we need to calculate is this index, and it's calculated by deviating every score in your distribution from the mean, that is subtracting it from the mean, and then calculating the square value of whatever you get, and then dividing it by n, and then taking the root square value of the index. That value will be your standard deviation. Standard deviation of the sample is represented by SD, but as you see in this formula, it has been represented by the lowercase sigma. When you use the lowercase sigma, we mean the standard deviation of the population, whereas this one refers to the standard deviation of your sample. In either case, I have already done a standard deviation computation for you. This is the same distribution that I just showed you before. It has got age in it. I've called it age. And in this column, I have deviated each of these numbers from the mean value of my distribution, and I've generated this column for you. For example, the first one, which is a 4, has been deviated from 5.45, etc., to generate this number in this cell. And the rest of them have been created in the same way that I generated the first one. The next step is you want to create another column and compute the square value. This is how you represent square value in Excel. And I've already done that too. You just multiply every single score by itself, so you'll get the square value for that score. Then you sum them up to get this part of the equation. I've already summed it up, so this part of the equation equals 34.72 something. At this point, then we need to go on and divide it by the sample size. So 34.72 divided by 11, which is our sample size, which gives you an index, whatever it is. That index, I've already actually calculated in this here, is also referred to as the variance of your data. Now, if you get the square root of your variance, you'll get the standard deviation. Standard deviation is very useful because it shows the amount of spreadness around your mean values. So the standard deviation is also represented here in a normally distributed population, which is much larger than the distribution that I presented before. There are some cool facts about standard deviations, which is very elegantly summarized in this figure. 68% of normal populations fall within 1 standard deviation above the mean and 1 standard deviation below the mean. In addition, 95% of the data in a normal distribution fall below and above two standard deviations above and 2 standard deviations below the mean. And finally, 99% of the data fall 3 standard deviations below and above the mean. That's altogether 6 standard deviations, 3 below and 3 above the mean. This is how you calculate the standard deviations and how you can represent them. The point is that the larger the standard deviation, the more widespread the data set is. So if you are really interested to get a homogeneous sample, one of the first things that you should look at is whether my standard deviation is too large or too small. But remember that standard deviation is not an inferential statistics, which means that it is only used as so-called a measure of dispersion and is purely descriptive. As I mentioned before, and I would like to reiterate it again, standard deviation shows how spread or how the amount of spreadness around your mean values, and nothing really beyond that. So it doesn't show whether your sample size has a higher mean score or lower mean score or anything like that. This is something that I have observed in some of my classes. Some students assume that if standard deviation is higher or lower, then your sample size has a better or a poorer performance. It doesn't really mean that. It just means how much spread or variability you have in the data. There's another concept which I see often is confused for standard deviation. It's the concept of standard error of the mean. It's very different from standard error, the standard deviation which I've discussed. Standard error of the mean, or SE for short, refers to how accurately your sample data represents the whole population. How do you calculate it? It's calculated by dividing the standard deviation of your sample by the root square of the sample size. For example, we have a standard deviation of 1.774 for our current sample and a root square of 11, which gives us a standard error of, actually we can calculate it here. Let me quickly calculate it for you. So standard error of the mean equals standard deviation divided by the root square of 11, which I've already calculated. And it gives us 0.535 more. And I'm going to round it off to 0.54. So our standard error of the mean for our sample is 0.5. Let me write it again, 0.54, almost. Now, how to report standard error of the mean? Standard error of the mean can be reported in simple sentences like this. The mean test score is, or was, in our sample was 5.45 plus minus 0.54, or standard error of the mean. This is very useful because it helps your audience or your readers to understand how accurate or how accurately your mean score represents the mean of a population. Now, this brings me to the final concept, which is confidence interval. And I think this is very useful and very important. So a confidence interval refers to a 95%. I mean, there are two types of a 95%, 99%. So let me just talk about the 95% one in this video. A 95% confidence interval is obtained as the value 1.96 times standard error of the mean, either side of the mean. What does it mean? Basically, you need to calculate the mean, as I have already done. That's 5.54. And then minus this value to get the standard error of the mean. So 5 plus minus 1.96 times the standard error, which was 0.54. This is basically your 95% confidence interval. This value I've already calculated, and if you calculate the value, let's call this x. Now, 5.54 minus x gives you what we call the lower bound, and 5.54 plus x, the plus sign, gives you the upper bound of your confidence interval. So this is how you can also write it. So the confidence interval equals 5.45 plus minus this index, which is equal to 1.0584. So the lower bound, I've calculated it as 4.3916, and the upper bound is equal to 6.50.84. How do we write it in reports or in papers? I suggest a simple sentence like this would be fine. So there is a 95% of chance, sorry, a word is missing, 95% of chance that the range 4.3916 to 6.5084 includes the mean of the population. So the mean of the population, in other words, falls between these two statistics. And it's also interesting to note that the mean of your sample also falls between this interval, is somewhere there. So this could be a representation of the mean of your population. However, I also note that the confidence interval is relatively large here because it has a wide spread. So the smaller this confidence interval, the better it is, because we will have a more precise estimation of the population interval, the population mean. Now, this brings me to the end of this video. Thank you very much for your attention, and have a good day.